Okay, so for problem 1, you are given that the linear velocity is 10 meters per second, the mass is 25 kilograms, the radius is 0.2 meters, the equation for the moment of inertia is 2/5 mass times radius squared, the height is 3 meters, and the angle is 25 degrees. So it wants us to find the total kinetic energy basically before it hits this ramp. So the kinetic energy is going to be equal to the translational kinetic energy plus the rotational kinetic energy because it is rotating. So translational kinetic energy is 1/2 mass velocity squared, and rotational energy is 1/2 moment of inertia angular velocity squared. But the angular velocity is also equal to the velocity divided by the radius. So I'm going to substitute that in for the linear velocity, and I'm going to substitute this moment of inertia equation in for the moment of inertia. And then after that I've got my equation, I go ahead and I plug in the given values up here for mass, velocity, and radius. And then I go ahead and solve and find that the kinetic energy is 1750 joules. So then for part B, it wants the magnitude and direction of the velocity after it leaves this point right here. So I did an energy summation, and the net energy before is going to equal the net energy after. And before there's just kinetic energy because it's going along a flat surface, but after there is potential energy as well as rotational kinetic energy and translational kinetic energy. So I broke down potential energy into mgh and rotational kinetic energy into 1/2 moment of inertia angular velocity squared and translational kinetic energy into 1/2 mass velocity squared. And after that, I also substituted then the for angular velocity, just the linear velocity divided by the radius, and I substituted the moment of inertia for the moment of inertia equation given up here. So after that, I go ahead and I plug in my numbers. The kinetic energy is going to be what I found here, because that's the total kinetic energy while it's on the flat surface. And then I go ahead and I plug in my mass and gravity, the height of the ramp, and the radius over here. And I simplify, and I get that 1015 joules is equal to 12.5 times the velocity squared plus 5 times the velocity squared. So I factor out a velocity squared, and then I solve for v, and I get the velocity to be 7.62 meters per second at 25 degrees because it's going to leave this ramp at 25 degrees, and it'll change from then on.